Right, we're down for that one. I can afford to take a little bit further back actually, I'll probably do that. The other one is a slightly smaller diameter, so I'll have to take a little bit more off for that one. What I'll do is concentrate on one at a time. And get this one sorted, then we'll do skim a little bit more off and do the next one. So I'll just clean that up, take that back a little bit further and cut a piece off for a washer. Now we've got that far, I need to drill and tap. I'll put an M12 bolt up the middle of it, so we'll drill and tap that out. So starting off with a centre drill. Just establish a start. We'll change over to put in there around about a 7mm. To go into around about 30mm deep. So use my tail strap line, start at about 10mm there. And get to about 40mm. The drill's not cutting the best, that one. I'm due for a really shortened session on some of these. Around 40mm deep. And we'll swap to a 10.3. Speed down a little bit. tighter one, putting in more evenly. This material's EN1A, or the modern equivalent, so it's free putting steel. All you need for this sort of a job. Right, I'll explain the, I've set up for tapping. I'll explain the setup here. I've got a spring loaded centre up against the tap with some pressure on it, so that'll push the tap in, and it's located in the centre point, back centre of the tap. So as we tap, it'll push the tap forward. There's just enough clearance with this this short handled tap handle to clear the saddle there. The gear, the lathe's in a low gear, so it's not turning in the chuck. And we can just tap by hand like that, and we know we're square. I'll just finish up with a bottoming tap. We've got it pretty well cut there. Clean out. A bit of oil up there. And there we have it, our thread is in. I've got I've cut a piece of another piece of bar off and just face it up a little bit in the other lathe just to make a thick washer. I've got a bolt slightly too long, so we've got a few washers behind it just initially. I'm just going to tighten that onto there and skim a little bit off the OD of that, just to make it just slightly under the minor diameter of the thread on the slider. We'll just clamp that on there like that. Set back up for turning again. That's a very light touch off it, just to reduce it down a little bit. efficient. Now we should put our slide seal holder onto there. Take a couple of them washers out. Yeah, that's it, just under there. There we go, piece in place, bolted up and turned down below the point where the minor diameter of the threads are. Next I'll put the tool, the threading tool in the tool holder, set that up, and then we'll take a look at setting the gearbox up for our 20 TPI thread. Here we are for setting up for cutting our 20 TPI thread. Using the table on the lathe here, if we go along this line here, we can find our 20 TPI mark. So from that we want D and A on this change box here. So there's our D and A set, and then this Norton type quick change gearbox slides along and drops in on that line for our 20 TPI. So that's that stage set, and then we've got another lever here with a neutral, a metric and an English. So for that one we need to be up into the English position for those threads. So that's that section set. We're going to be cutting in the normal direction, so a little bit higher up on the headstock on this Colchester student lathe. We've got a lever for our lead screw direction, and that's already in the correct position, moving from the tailstock end in towards the chuck end. So that'll give us our normal right hand thread. I'll just reposition the camera and show the setting for the speed up here. And now for our speed setting, we want to be at the slowest speed possible for this one, just as we're cleaning up existing threads. So on our gearbox there we've got 54 RPM. The speed changes are always done on lathes, or these type of lathes certainly, with it not running. Never change speeds with the lathe running, you'll destroy the gearbox. So in the first instance we can see this lever, which is representing this one, is over in that direction. So we'll change him over there and just rotate the chuck if need be to make the lever drop in position. And then on this part here there are two levers which represent the top levers here, and they should both be facing inwards. So again, rock the chuck slightly and engage both of them, and that's them in place. So we're now at the slowest speed. I've also got as I've mentioned before, a variable frequency drive on this lathe, so I can slow it down. I'll drop the camera down and just show you that out of interest. This is our
our motor control panel on a Colchester lathe. Anyone who knows these round head Colchester lathes. Originally this was a master on-off rotary switch. When I got this lathe it was 3-phase originally, so I needed to convert it to either convert to single phase or run it on an inverter or a trans-wave converter or something. Everything else I've got is on variable frequency drive, so this got the same treatment. So this pot now is an additional speed control that's connected to the inverter. I've built the inverter into the cabinet itself. If we open up here, we've got our inverter in position. The cabinet was extended deeper, and some extra cooling vents are in at the top for allowing air circulation on there. The motor has to be changed over, the motor connections to run there. There's a copy of the original thing that's in the paperwork that's in the motor. It's currently set to delta for 230 volts, which is what we get out of the inverter, 230 volts 3-phase. I'll probably do another video at some point in the future going through that. Okay, back in a moment.
Here we are running at in our low gear plus with the inverter turned down well. One important thing to do with screw cutting of any sort is making sure you keep the lead screw free of any contamination, especially on these older lathes without lead screw covers, and pop a bit of oil on it when you're going to do any sort of screw threading. And then clean it up afterwards when you've done.